Hi, my name's Andy Ramgobin and I am the CEO and co-founder of CodeZero. Today we're going to be talking you through yet another cutting-edge workload for high-performance compute that we're going to be running on our immersion cluster, which is made up of 3 Dell R750s, which were funded by Intel, which were converted for immersion by Unicom Engineering, and sit in a Green Revolution Cooling micro tank, which houses Castrol's DC15 immersion fluid. We're going to be running you through computational fluid dynamics running in Ansys Fluent. So we've got a screen capture for you. You're going to see something sped up today on the screen right now. You can see we're building a mesh, and this mesh is of an R640 Dell PowerEdge server sitting in a GRC micro tank. And the purpose of what we're doing today is to really show how we can use Ansys Fluent, which is a CFD and engineering software, to run computational fluid dynamics simulations. And we've worked really closely in partnership with GRC so that we can say we're running CFD simulations for immersion cooling on immersion cooled servers. So we're using a free trial license provided by CADFEM in the UK, and that's for Ansys Enterprise with 3 HPC packs. And as you can see, we're about to go into Fluent. We're using double precision on the solver options, and we're going to run this particular simulation on CPU only. Because we've got the Enterprise license and our servers have A40s, we can run these simulations on GPU, and we have. But for the purposes of this particular showcase video, we're going to be running it on 64 core virtual machine, which has 128 gig of RAM. So again, we're going to speed up a portion of this video so that you don't have to sit here watching things happening on the screen, but I'm going to talk you through what we're doing and how we're setting it up. So as you can see, we're loading in the mesh. We then have to check the mesh when it's complete, which is going to run through a couple of checks. And after we've loaded the mesh into Fluent, we're going to set up the simulation using parameters that GRC have given us to give us the accurate results for this particular showcase. And we're going to see how long this simulation takes to calculate. So typically doing a simulation on timescale factor 1 with 500 iterations will allow us to run a larger number of iterations and get to a point where we can get a stable and accurate results on our simulation. So I think you can see now that I'm going into Fluent and I'm going to be setting up some of the solution parameters. One of the reasons that computational fluid dynamics is such an important area for us is that it's a true HPC workload, and there are so many different applications for CFD, especially when we look at things like data centers, Formula One racing. There's so many different applications, and we know that the design that we've done in the data center is perfect for CFD. We know that the A40s are perfect and optimized for CFD. So what we've done is we've created a virtual machine on our Nutanix cluster, and because our cluster has 10 gig copper-based T, so we're on a 10 gig backbone, we've decided to make sure that, because we're running a virtualization cluster, that we pinned the virtual machine to a specific host, and that most of the resource, not all, but most of the resource is running on a specific host. So there's always a virtualization overhead in terms of performance than running something like HPC on bare metal. But because we're using Nutanix, we believe that the increased performance of storage kind of outweighs the negative overhead that we get from running virtualization as opposed to running bare metal. So as you can see, I'm starting to kick off the simulation, and we've sped up this bit. So again, you don't have to sit here and watch it go through the simulation. And we've run a number of different simulations. We ran it on a single core. It took, I think, about 11 hours. And then when we ran it on 64 cores, we were up to about 31 minutes. And then when we run it on GPU solver, it's almost 3.5 times faster, and it's coming in at around 9 minutes. So we can see straight away that if we use the CPU cores and we use GPU, we're able to crunch this simulation far quicker. There are some limitations on the GPU solver. Some of the features are still in beta, so you have to be reticent or aware that at least that depending on the simulation running, you need to understand whether you're going to need more RAM, whether you're going to need more cores, and whether you're going to need something like the GPU solver. So simulations run now, and I'm going through a process with GRC right now, looking at how do we run some post-processing. Now there's so much stuff to show you here that we've skimmed it down to a very MVP, minimum viable product level, whereby we're choosing one of the heat sinks for the CPUs. We're going to create a plane that mimics the tank and the plane of the heatsink. And what you're going to see in a moment is me go through some options in Ansys, which are going to show us what the fluid flow and velocity of that fluid look like when they're passing through the actual heatsink in the tank. So this is really compelling stuff. This is something that all immersion vendors have to do in terms of running CFD simulations for heat transfer for CPU and GPU, to look at how the coolant and the oil will move around the tank when there's particular load. So what we're trying to do here today is show a cut down version of what we can do, but show something that's still really compelling, and show that absolutely that we can do HPC in immersion on Nutanix on 10 gig. And to give you an idea, Fluent does give you some good benchmarks. So we prefer to use Prometheus and Grafana. We've built a number of dashboards where we can see GPU temp, we can see, how many cores are being used, how much of the memory is being used. But Fluent has its own native performance metrics. And one thing we've been able to see with this particular simulation between core latency and the CPUs, we're looking at 0 milliseconds to 1 millisecond. So you take somewhere in the middle of that, 0.5, we're running at something close to 100 gig InfiniBand, and we're doing it on 10 gig copper. So I really hope you've enjoyed just a very high level view and demo of what we can do in immersion for CFD. And the next stage of this project is to do something with a university racing team, where we're going to be running some aerodynamic simulations, and we're going to be running these again on Ansys on our immersion cluster. So thank you once again. My name's Andy Ramgovan, and I'm the CEO and co-founder of CodeZero.